Okay, welcome back everyone. We'll cover module 3 in this video. In two videos, we'll cover half of the module, which is enough for examination. We'll look into L2 parameter regularization, that is nothing but also called as weight decay. So basically, we'll understand why do we need regularization. In deep learning, regularization means making changes to training. So the model performs well not just on training but also to new or test data. So basically, we don't need regularization. We need regularization because the model which you are using to to train the data or to test any data, it needs new data every time or some change in the data, so that it can work on different things. So for example, if you study one topic, like suppose there is a topic, big topic, understand L2 pattern regularization is the topic. They might ask what is it define, or they might ask explain the weight decay process, or they'll ask a question like explain the equations of this. So there are three different questions, but they all are from one same thing, right? So different questions help us understand this one topic. It's just like that, okay? So the same thing they have written over here. So here what it does, it makes sense of the actual data, so that the model performs well on not just on training but also new or test data. A very common regularization method is adding a parameter norm penalty. This is a general thing. We are not talking about this yet. So now we are talking about this, where after telling this by adding a parameter norm penalty, that is basically nothing but this uh, yeah, ohm theta. Okay, so here key idea. Okay, so we modify the objective loss. So first we have to talk about the parameter norm penalty has a what to say it, loss function. Okay, objective function that is also called as loss function. Just have to remember this one thing. J cap. So actually you can draw tilde or you can draw this also. Both are same. Uh, Theta xy. So same thing will repeat without the cap plus alpha into omega ohm theta. So here alpha is a like kind of parameter type of thing, like hyperparameter. This is the parameter and this is the penalty. See, we saw here, right? Parameter norm penalty. So alpha is a parameter and the penalty is this. So here penalty will be a fixed value, but based on alpha it will differ. So how, see, penalty term measures size of parameters. So alpha is nothing but hyperparameter controlling the strength of regularization. See, if alpha is 0, then there is no regularization. But if alpha is very large number, then stronger regularization. So just remember that. Okay, so what is ohm theta? That is a penalty term. So j theta xy is nothing but original training loss. This is new training loss, just think like that. Important VTU point: bias usually not regularized. So remember, in regularization, only the weight which we add is penalized, and the biases are unregularized. So we don't do any changes in biases. We only make changes in the weight, because biases are easy to fit and regularize them can cause underfitting. So underfitting is something where you are not using or taking as much of data is required. Like for example, if you want to study this topic, underfitting means you're just studying a definition and just going for examination, but you're not studying the actual examples, these equations, all the real world example. You're just studying the definition. That is underfitting. Overfitting, you're studying the whole textbook, each and every line too much, which is actually not required for the examination. The best fit is nothing but what I have extracted in this PDF. Then we have L2 parameter regularization. So what is it? So L2 regularization is also known as, aka also known as weight decay, which adds a penalty that pushes weights closer to the origin, that is 0. Origin is always 0. So you can extend this definition as well by looking at textbook. So the penalty term, so here it was about normal regularization thing, but in L2 what happens, this, see, we have to talk about actual penalty term. So now in L2 reverse time, this penalty term value is different. What is that value? This half 1 by 2 W. Actually, this is 2 like this in the textbook. So now what happens? If you just have to replace this ohm theta value with this. So instead of this ohm theta, alpha into this will come. Since alpha into 1 by 2 is alpha by 2, that's why we are taking alpha by 2 into W. See, it's just like that. So other names must mention ridge regression, Okay, what is it? Regularization. So real world energy weights are like important values for features. Without L2, the model can give huge importance. Sorry, without L2, model can give huge importance to random noise features. In the sense, overfitting. Like I said, if there is no proper guidance, like for example, you're trying to study, and suppose I'm the penalty term, or I'm the L2 thing. So without me, you will be studying too much, searching here and there. You're overfitting. You're doing too much. But with the help which what I'm providing the help, you don't have to worry much. You can learn from my explanation. If you want to skip that, even more good penalty thing is you can just see these notes and study by yourself. See, it's just like that. With L2, model is forced to keep weight small, more stable decision. Okay, so like I said about reducing this PDF, let me talk about this platform. This platform is very good platform where you have to see it's just 400 per month and 800 per month for pro feature, where see you will get 50 credits over here, and you have very big AI tool. You just have to upload the PDF. See, you can upload the PDF, not a textbook. Remember not to upload a textbook. You can copy the content of the textbook and make module wise PDF, upload it, and you can see it's saying by itself summarize this or what. You can actually ask him to explain it very properly. Smart notes. By giving the whole module notes, you can generate smart notes. You can generate flashcards, like each topic wise one small explanation, and if you turn, you will have some image, and then you can ask him to make the quiz for the topic. Suppose you're preparing for exam, you prepare everything, you'll upload the notes which I made. You can just ask him to make quiz, so it will make quiz. If you want to explain the topic, so this is how I have been making the notes for myself. It has it makes study roadmap, the way how I decided which module is easy. If I have to show you the syllabus copy, I decided is the highlighted topics are the easiest topic, and it will cover the almost half of the textbook, and it's more than enough for me to cover the exam. This are all helpful by this actual smart AI tool. You can actually, if some videos have script and all, what is that subtitles thing, you can just paste the link and to analyze and explain the video as well for you. Then you can and whatever you have generated, you can easily download it. You can download it into doc format, or you can download it to PDF format. You can also upload in multiple formats as well. So this is a very good AI which I recommend you to see. Actually, I'm already using, and some credits have already been used. So you have see a dashboard which says what I have done so far, the everything, like all the things and all. Quick seconds so far. I have it's got resetted, but the current thing is not shown right now. So you have all those you know ranking and all. It's all very engaging and very useful for us. So you have all input uploading. So I've used this a lot. So I had to change the account and use the credits again for some other explanation. So the other account which is like ran out of credit, so I had to switch the account and use here. But anyways, this is a very helpful account. The actual exam helper account was being used for this, but you have to use this AI tool. You just have to search studygvi.io. This I'll be providing in the description. Anyways, let us move to the actual notes. So here now how L2 actually works during training. So now what you have to do, gradient. So there is one step, gradient step, gradient descent. See, one step here. This key step is gradient, weight update, that is gradient descent. So what is happening in the gradient key step for L2 descent? So you have to see this is a gradient, okay, multiplied by j cap of w is equals to, see, the same thing will repeat again the same way in the actual like universal equation. You can understand for regularization how same thing was here. Here alpha is also there, but what, instead of ohm theta you have w. See, instead of ohm theta you have w, and then instead of that whole big thing you have same. Now what happens, you just have to multiply this whole thing with w minus epsilon. Now multiply minus epsilon inside this bracket. You will get minus epsilon alpha w minus epsilon into delta w. So here you have w common. So w minus epsilon alpha w. So just take the w outside. 1 minus epsilon alpha. See, that's it, finished. So this is the actual regularization, meaning before doing the normal learning update, the weights get multiplicatively shrunk by factor 1 minus epsilon alpha every step. That's what That's why it's called weight decay. So what happens, these steps keep on repeating for every test, for every data. So with this factor, the weight keeps on decaying, reducing. Sometimes if it is not suitable, it will reduce to zero. That is L1 regularization. But here we are using half, so we are not reducing directly to zero. Sometimes what happen in L1 regularization, you have also L1 regularization, in which the weight, sometimes it is not, it's, if it thinks it's not that useful, it will completely shrink it to zero. But here it won't shrink completely to zero. It will reduce little. Then it will close to zero. If it is not required, at the end it will be at zero. Which is required, it won't decay. It's acts like that. What happens over the whole training? Institution for full marks. Say L2 regression keeps only useful directions in weight space. If a direction strongly reduces loss, keep relatively intact. Your direction does not help much, shrunk close to zero. So it's not shrinking directly to zero, but close to zero. Textbook explanation uses Hessian eigenvalue, in the sense, in the textbook you actually use an Hessian eigenvalue. Eigenvalue is nothing but lambda I divided by lambda I plus alpha. So here, what component shrink factor? How to shrink the weight to zero? So if lambda I is too much bigger than alpha, then little shrink. If it is too much lesser than alpha, stronger shrink. Equal to alpha, no shrink. Near zero. Okay, understood. So here L2 removes weight in unimportant directions and preserves weight that matters for reducing objects. For example, if it is there is a maze, then if there is a long path, is not required, so it saves us from walking to that trap path. It's just like the linear regression form. So for linear, by chance, if they ask L2 for 10 marks, you might have to mention the linear regression thing. L2 changes the solution from. It's very simple. See, the only thing which is being added is this. That's it. So W is equals to X. You write 3 times X, 1 with T, 1 empty, 1 with Y. Okay, so 2 with T and 1 with empty, 1 Y. Say Xt into X whole inverse into Xt of Y. The only thing adding alpha L. Adding alpha will increase the diagonal. Model perceives higher variances, shrink weak features. So when to use and when not to use L2. So when to use L2, when the model is overfitting, when you see overfittings happening, when you want smooth stable weights, then default regularizer for deep nets, weight decay. So default C, once the factor is set now, like continuously it will be applying for every training data, and it will be decaying. When it is not ideal, when you specifically want sparse weight or feature selection, 11 is better for that. If alpha is too high, causes underfitting. So see, it's not ideal for that. Advantages: improve generalization, making training more stable, reduces variance by limiting parameter magnitude. Disadvantages: need tuning of alpha. So you need actual good alpha value for that. If you use some wrong value, then it will lead for wrong regularization. Too much regularization leads to underfitting. This is a quick summarization table. No regularization, weights can grow large. Overfitting, example memorizing training data. L2, weight decay, adds alpha by 2. Then L1, contrast, makes some weight exactly zero sparse. See, here it will slowly reduce to zero, but in L1 directly reduces zero. That's it. We'll see in the next video about okay, so we'll mark here which we have completed, that is parameter norm penalties, L2 regularization. Next we'll see of dataset augmentation and semi-supervised learning, which is the smallest topic. We'll see in the next